Welcome to our video on measures of dispersion. So this is going to be one of the more challenging topics. So let's jump in with the least of these. So first of all, when we're talking about measures of dispersion, okay, what we mean is how is our data spread out? Okay, so let's say that our data points, okay, are 7, 4, 3, 9, and 2. Okay, well, the first thing that we want to look at when we're talking about how is our data spread out is range. Okay, and range is nothing more than the largest value minus the smallest. Now, where a lot of students make their mistake is they say, oh, well, here's my data set, 74392. So this must be 2 minus 7 for the range. And that's not it. Because in order to do the range, we do need to rewrite from smallest to largest. So just like we did with measures of center when we were trying to find the median, when we are looking to find the range, we also want to write these smallest to largest. So let's rewrite these. So we have 2, and then 3, and then 4, and then 7, and 9. And now you can see that 2 is the smallest, and 9 is the largest. So in order to find our range, we're going to say 9 minus 2, and that is the range. So that tells us how much space there is between our smallest data value and our largest data value. The big thing to remember here is that we always want to rewrite our data set smallest to largest. That needs to be our first step for measures of center and measures of dispersion. Now let's continue with these data points. So suppose you are planning a trip and these are the prices that you found, for whatever part of that trip we want to talk about. Okay. Whether that be like renting a car, a hotel room, maybe you were able to find some really cheap flights, but you want to find out like what is the standard deviation. Okay, so standard deviation, this is another measure that tells us how our data is spread out. Okay, so it is usually helpful when we are calculating our standard deviation to set up a chart. Okay, so let our data values be our X value. Okay. Then something that is important to know is the mean. Okay, we need to find the mean. And the symbol that we use for the mean is this thing called X bar. Okay. So recall when we find the mean, we add up all of our data values. And then we divide by the number of data values that we have. And that gives us the mean. Okay, so the mean of this data set is $210. Okay. So we have our data values. Then we have what is called deviation from the mean. And all this is saying is how far is each data value from the mean? Okay. So we want to start out with this. So we have our data values 195, 213, 208, 219, 210, and 215. Okay. So how far is 195 from the mean? Well, 195 minus 210, which gives us that this data value is $15 below the mean. Okay. And we do that with all of these. Okay. Each one of these, we calculate how far it is from the mean. Okay. And yes, it is possible to be 0 away from the mean. Okay. All right. So now we found out how far away each one of these is from the mean. Okay. So the next thing that we need to do is we need to take each one of these values. So x minus x bar, and we need to square it. And the reason why we're going to do this is so that we eliminate these negatives. Okay. So negative 15 squared gives you 225. 3 squared gives you 9. Negative 2 squared is 4. 9 squared is 81. 0 squared is 0. And 5 squared is 25. Okay. Now we need to find the sum. And you're going to see this crazy looking E. Okay? This is sigma. And it means sum. Okay? So we're going to find the sum of all of these deviations squared. So all we're doing here, we're adding 225 plus 9 plus 4 plus 81 plus 25. And that gives us 344. Next thing that we need to do is take the sum of our deviations squared and divide it by the number of data points minus 1. Okay? So we have 6 data points. So we're going to do 344 divided by 5, which is going to give us approximately 68.8. Now, in order to standardize the deviation, we now need to take the square root of the sum of our deviations squared divided by n minus 1. So that's going to give us the square root of 68.8, which is going to give us approximately 8.29. Okay? And what this is telling us that when we standardize these scores, the deviation from the mean kind of averages out to be about 8.29 away from the mean. Is kind of the average distance from the mean for every one of our data points. So what this basically tells us is how tightly packed or how loosely packed our data is. When we're talking about hundreds of dollars and a standard deviation of $8.29, basically, all of those prices are pretty close together. And we can see that with such a small data set. Standard deviations really come in handy when we have a very large data set. And that's what we're going to take a look at next. Okay, so let's say that these are the prices, or the closing prices, for a particular stock that we're interested in buying. And we want to know, is this a good stock to purchase? So we have the past 20 closing session prices. And if you notice, there are some numbers that are repeated here. So if we just write down the single values that are there, 37, 38, 39, 40, 41, 42, and 44. And what we're going to do here, we are going to, well, if I can draw a straight line, we are going to create a frequency table. Okay? So how many 37s do we have? Well, we only have one of those. We have 2 38s, 5 39s, 5 40s, 4 41s, 2 42s, and 1 44, for a total number of data points of 20. Okay. Now, if we calculate the product of each of these, we can find out the average or the mean. Okay. So 37, 76, 195, 200, 164, 84, and 44. And when we add all of these up, we get that the sum is 800. Okay. And 800 divided by 20, that gives us 40, which is our mean. Okay. So now what we want to find out next is, what is the deviation from the mean for each of these data values. Okay? So recall that what we want to do is we want to take the data point and the mean and subtract them. So we end up with that data point is 3 below, that's 2 below, 1 below. That is exactly the mean. That's 1 above, 2 above, and 4 above. Now we can square all of these so that we can begin to standardize this. Okay, so we get 9, 4, 1, 0, 1, 4, and 16. And then we can, because this is a frequency table, we need to take our deviation squared. So our x minus x bar squared, and multiply that by the frequency. So each of these is going to be multiplied by the number of data values. So the first one is going to be 9 times 1, 4 times 2, 1 times 5, 0 times 5, 1 times 4, 4 times 2, and 16 times 1. Now, if you recall, our formula for standard deviation is going to be the square root, okay, of our sum of the deviation squared. Since this is a frequency table, we're going to times our frequency, okay? And we divide that by the number of values minus 1. So this ends up being the square root of 50 when we add up all of our deviation squared times frequency divided by 19, which gives us a standard deviation of 1.62. Now, what does that tell us, though? Well, what that tells us is that this stock only varied by about a little more than $1.50. So $1.62 over the past 20 trading sessions. It really only varied by a little more than $1.50, which basically means that this stock is probably a pretty good buy. Okay, so this is how we can tell if a stock is good to buy or not. Okay, because something else that we can look at when we're looking at measures of dispersion, we can look at something called coefficient of variation. Or you might see it abbreviated just CV. Okay? And to calculate the CV, we are going to take the standard deviation sometimes represented with S, and divide this by the mean, or X bar, and then multiply that by 100. Okay? So, if you are told that the standard deviation for one stock is $23.16, and the mean is 203.63, then that means that this coefficient of variation would be 23.16 divided by 203.63 times 100, which gives you 11.37%. That's the coefficient of variation. Okay? So let's say that we have another stock that we're looking at, and this one has a standard deviation of $3.70. It has a mean of $30.79, which means that the coefficient of variation is going to be 3.70 divided by 30.79, and then we multiply that by 100, and that gives us 12.02%. Now, this is really important when we're looking at something like stocks, because although stock number 2 has a smaller standard deviation, so we think, well, it's varying much less. Well, we have to look at that in comparison to the price of the stock, or the average price of the stock. And when we compare the two, we see that the second stock here has a much higher coefficient of variation. It has a coefficient of variation of 12.02, which is higher than stock number 1. Because it has a higher coefficient of variation, this stock is actually more volatile, which means that it is more likely to vary in price. And while that could be a good thing, because that could mean that we would stand to make a lot of money if we purchase this stock, if it varies a lot in the positive direction, it could also vary a lot in the negative direction, which means that we could stand to lose a lot of money. So if you're looking for a stock that's extremely volatile, has great swings up and down, then you want to go with one with a higher coefficient of variation. However, if you're looking for a stock that is, kind of a sure thing, or more of a sure thing, you want to go with one with a lower coefficient of variation, because that means that it is less volatile. So I hope these notes have helped. Please reach out if you have any questions. We will do all we can to help.